Hi everyone, today we're gonna be recording the video for your exercise 4, and basically in this video we're gonna be calculating the total water demand, then we're gonna be estimating the water supply, and finally we will be doing a mass balance. So buckle down and then here we go. So at some point in your HydroLearn you will be in this part where you're asked to estimate the total water demands. So for this case I have already opened this, which is save a copy of the water budget spreadsheet that is there, and also having here the instructions of the document. Okay, so let's get going. So the first thing is that we will have to make a summary of the total urban demand, well, the total human water demands. So in this case we're going to go to this cell and so this will be for the previous one. In this case C. So basically here what we're going to do is in this cell C6 we're going to link it to the one that is this is basically, if we will go here and we have our projected urban water demand, which we know is this one, and that will do in there. We can do the same for the rural one. This will be the rural. So we can actually copy this one and paste it for until 2025. What I'm going to do here is paste this one as a formula, because otherwise it's gonna mess up the format behind it. So that's what I'm doing it, and I'm gonna do the same with this. Sorry, just copy, and then I'm gonna paste it as formulas. And there you go. Now for the agricultural one, and you can see that we have all of that. We have now all of this. And for the agricultural one, here in G6, we need to go to AD 14 of applied water. So we can go here to applied water, and that will be AD 14, which is AD 14. This is the total demand. And then we can also do this. Once again, that will do it. Okay, so now we have these three. What I'm going to do is to, in this column, add the three of them. So it will be this plus this plus this. So urban plus rural plus agriculture. And the same, I'm just gonna copy and paste it as a formula, and this will not mess up our formatting here. Now what I'm going to do is to create the percentage of this year of the urban demand compared to the total. So it will be this divided by, and then we can say this one, but I'm gonna fix it, but I'm just gonna fix the column. So in this case, I'm just hitting F4 until the dollar sign is before the letter of the column, which is I. And basically that's what is doing it. Again, I'm just gonna do this as formula, so it doesn't mess up with the format. And I think if I can do this, I can exactly do the same, but and that will do it in here, and and there we go. So see, 84%, 6%, 11%, 13,483, 13,483, and 100. So now what you need to turn on is a graph that shows these three columns. So something that you can do in here is actually to unlock this one here, and I'm just gonna name this one before. If you hit F2, you can actually access directly to the cell. Sorry. And then this last one, there you go. And what we can do is select first this first column, then you can hit Control, and then you will have to drag it and keep pressing Control until 2050, and then we'll do the same for agriculture. Just keeping holding Control. Once we have this, we can do insert a chart, and we're gonna select the one that is actually stacked. So a column chart, but that is stacked. There you go. And the one other thing that we can do here is add the x-axis, which in this case will be the years. And there you go. Now we have that one. You can change the colors and so on. And now let's estimate the monthly variation. And to estimate the monthly variation, what you can do is, okay, so basically here we're going to 06, and if I remember correct, we need to link it to the projected one that we already estimated in urban water demand. So this should be, I think it was in here. So we already have these values. See? And again, I can copy and paste it as only the formula. We can do the same for, and here we are right now. Now we can do the same for rural, which that information I think is here. And now we need to calculate the one for agriculture. And in this case for agriculture, so if you take a look at this value here is the, if you remember, this is where we calculated the demand for 2020. So the total demand is for 2020. This is also for 2020. And then we will use this to also do it for 2020. Sorry. Well, so let's copy this formula in here. But basically what this formula is doing is multiplying. If you look at this, it will multiply this 2020 value times the monthly distribution of the applied water for these specific months. So AO13 over AO25. So what is doing this one is AO, this one. So it is dividing this monthly value over this total to estimate what is the percentage of January that typically is used. Okay, we are just calculating for 2020 as a reference right now, just so we know how much of that is to have an estimate of how much water will be used annually, considering 2020 as a reference year. Okay, so we have now that, and then if we add it up, this will be yes, 41 2014. And basically now what we need to do, that the total is the sum of those three. There we go. Yep, and now you see that we have this 49,866. Now we need to calculate the percentage for each of these. And this is actually not that difficult, so again it will be this divided over this one, but this, in this case, we will have to fix the column. So now I hit F4 until it goes into this way. And I just need to copy the formula, copy this value as a, paste it as a formula. And then once I have this, I can do exactly the same. Sorry. Well, actually, you just can select one. That will be it. That will be it. Sorry. It didn't kept it copied. I see you have to copy it again. There you go. And remember that the precipitation, if I remember correct, here is in applied water. And here. Okay. So there you go. We have now this same table in here. And now what we need to do is something like this. So once again, I think here what you can do is just hit, select, well, add urban. Here you can add rural. And then here you can add agriculture. And what you can do is just select this. Forgot this one. Now you can select the 4 of them and we can create that chart. No, this one not. There you go. So there you go. We have all of them. Now what we need to do here in series is to change precipitation to the right axis. So now we can actually see it. And I'm gonna keep it very light so we can draw later a line. If we go back here, we can also add the x-axis. Okay. And I think in this case they should be stacked. So we are having something similar like that. What we can do, in order to create this also as a line, again what we can do is, just give me a second, let me get this out of our way, this one also, there you go. We're going to insert a drawing. Here I have copied the thing is, oh yeah, let's actually do it again. So insert drawing. I have already copied the chart, so here I'm just gonna hit Ctrl V. It will link it directly. And now what we're going to do is just to draw very easily a line to the top of the columns. And then here again, double click. Here you can also change, for instance, if you want it thicker. Also here you can add it if we want it like in this way. And I think here in color we can keep it like this. So let's see, this one I think it looks good, right? There we go. So now as you can see we have something that really resembles what it was asking the tutorial. Okay, then you will have to describe the difference between when water is needed and the precipitation when we have water available. Next, here as you're gonna keep working on your HydroLearn, you're gonna see that it is explained this part of the recharge from precipitation, which is this, and it basically shows the two equations. Basically that is precipitation minus the evapotranspiration, which is ETO times Kc, so this is now being explained, times the area of production, and the area of production is the area of a given crop times the acreage factor if the precipitation is greater than the crop evapotranspiration. That will be for precipitation. We'll come back to irrigation, but basically is the portion, so the portion that the plants could not take, it will be recharged to the soil. And recharge from irrigation will be the applied water minus the effective ETC times the production area. So the applied water minus this ETC effective times the production is that irrigation inefficiency. So this is how you will calculate the irrigation inefficiency, and that's how you are going to, in this case, this area production is explained out, is extended out, but basically that's what we're going to calculate. So let's go back here and start calculating our recharge from precipitation, and these equations also come here. So the first thing that we're going to do is add the precipitation. So we'll go like precipitation minus evapotranspiration and then the area factor. So let's go here, and here in precipitation, which is still D96, we're gonna copy this one, which is bringing information from the evapotranspiration worksheet. There you go. Now what I'm going to do, is paste it until 2050. Once again, I'm just gonna do paste special formula, and there you go. For the reference, then once we have all of this, You can compare it, 0.13, 17, okay. Now we're going to cell C96, and then we're gonna copy this value, which is basically bringing information of reference evapotranspiration from that specific one. Here you can just double click and this will do it. That will be easier. Crop coefficients will bring it back from the crop evapotranspiration sheet, and that will be this one. And once we have it this, then we can paste it as a formula and everything will be filled out. Okay, now for the acreage factor, you can see that first we need to estimate to bring the crop area. In this case here in strawberries, what we are going is to cell E28, so E28, which is here, and we're gonna bring the information from applied water. And remember that we have discussed this before. This is the historic and then proposed water for the future. Remember here that only first paste the one that is only inland until here. And this will do it. And then here in cell M28, which is this one, paste this formula. And then what I'm going to do is to copy this one and then select until here, and then just paste special as formula only. And this will bring all this entire data set. The last thing that we are missing is the acreage factor. And then this is from here. So here in P9, which is this cell, P9, here we're going to, did it like that, and then we can, there you go. Okay, I'm just pasting it, and I'm gonna copy this value and then paste it underneath. Then we have these two. Now we need to calculate the recharge from precipitation, and basically it will be this very long formula, which basically saying that, which is the equation that we discussed before. So basically it will be, in this case, there you go, this, so precipitation minus ETO times KC, precipitation minus ETO times KC, times the acreage of the area for a given crop times the acreage factor. So that's what this formula is doing. Basically, I think we need to go here, cell E96. So in E96, we will do this. And this has to be maximum of 0, so it cannot be negative numbers. So in here we do that, and that will start calculating this, so 280.26, and then we just need only copy this only for inland. So we can do this until here. There you go. And yep, it calculated that for inland, right? Now we'll have to do the same procedure for So this was only for inland. Now we are going to M96, which is here. Then we're going to copy once again this very long formula. And something also that you can do is now do this, and now sorry. So I'm gonna drag it all the way until cell column T, and that will do it. Finally, what we can do in here is calculate the for native vegetation here. Yes, that's correct. So we need to go to cell here U96, and now copy this formula. Which all of them, they are repeating the one that I was talking to you at the beginning, and now we have that. So 438, 325, 3139, 217, 86, and now we can calculate the total recharge, which it will be the sum of all of this. And again, super fast, that will do it. Now we can estimate, these are monthly values, we can estimate this annually, right? So in this case, we'll go here to this cell X28, and then we're gonna sum all the ones that are of that given year. That's what this formula is doing, is summing all of those that are of year, in this case 1990. So basically it's going to this column and is looking at these year values, and anything that is aligned with 1990, it will add it up, and that's why we have that value, which is 8,036 feet. Now what we're going to do is just paste it special as formula. That is because I don't want to mess up with the format. So once we have in that, then we're going to sell AA27, which is this, and then we're gonna calculate what is the average use on January or February or March, the recharge, the average recharge. So correct, once again as formula, and then here we're gonna sum all of them. There you go. Now in here, I'm gonna lock this up, so that's what I'm hitting F4, and again I'm just gonna paste it as formulas, and in this case I'm gonna bring the precipitation from, I think, is it here? Oh yeah, you can see. Okay. There you go. Okay, so now we have that, and then what we really want to have is a image like this. So what I am going to do, there you go. So we'll select these two and then add a chart. And in this one, I'm gonna say that it will be like this. Okay, here now what you can see. Okay, so this x-axis is not correct. So our x-axis is, sorry. It's this one. Now we're gonna, okay, let's come here. No. I'm gonna add a series, and this series will be the recharge from precipitation. And you can see that this is too large. This one I'm gonna remove. And now here I'm gonna once again add them. This one. Now this one is not visible because it is very small. So here I add it to the right axis, and voila, it appears. So there are some questions in here. Now we're going to calculate the recharge from irrigation. These are the different variables, and basically, if you remember, so this is the equation, or we can come back here, and so we already calculated the recharge from precipitation, which is the water that rained that the plants were not able to evapotranspire. And this recharge from irrigation, it will be the water that is in between the applied water and the actually water that is needed only to supply water for the crops, the effective crop evapotranspiration times the area of production. Well, this will be to calculate the volume. And I think in this part right now, yeah, we're in this part of estimating this aquifer recharge. And you can see here the rubric. So let's get back here to our two documents. And okay. Okay, so we need to go here, which is C17, and then we are going to, in this case, bring the inland land use from that specific cell. And I'm gonna copy, and I'm gonna copy only the ones for inland, and I'm just gonna see paste special as formula. And then I'll go to K17, and I'm going to use the following formula. This one here. There you go. And I'm gonna do the same. I'm just gonna here. I'm just going to have a paste it as formula, and then we have all of these this table, right? Now for this part, which is in here, this in C8, this value should be this one here. Okay, and then I pasted there the other one. Now to estimate the water from irrigation that it is in here, explain, so it will be the applied water, which is coming from this sheet, minus the evapotranspiration, the effective crop evapotranspiration, that it is come also from a time series data, times the acreage, which it will basically look at that acreage in this table, times the acreage factor, which is these two. before 98, so that's what it has. If it is before 98, then use 0.7, otherwise use 0.8. So let's do that. Here and paste this formula in C85 in here. So now that we have it, we can use it for all the inline, and I'm gonna paste it as formula only, and that will do it. Okay, now I have to go to K85 and then copy and paste this formula, and similarly notice that when there is no irrigation, which is basically January, so December, January, February, are the months that the values are 0. So November, December, January, and February. There you go. See? January and February, and also some of these might be November, December, January, February. And now that we have all of those, the total recharge will be the sum of all of this. Now here we can double click and it will be calculated. 570, 354, 4, 755. Okay, so we're good. Now we can estimate the annual recharge. And basically this recharge due to irrigation, which is from this, here in cell U17, we're going to assume all the values that are, in this case, for the year 1990, which it will be here. There you go. And I can use this one and paste it for until 2050 as formula. Sorry. Okay. And this will do it. And this other one that is recharged from precipitation we already calculated in the previous sheet, which, if you remember, it is this. There you go. And then here we can calculate the total recharge as the sum of these two. Okay. So here we have these values: 793, 23, 204. Now what we can do is to calculate the recharge from precipitation, and this one will be calculated as, in this cell C16, I'll have to use this equation here. Okay. And then we have to do the same for, so we can use, and we're just calling this value from the sheet that is precipitation recharge. And then we can copy this one and paste it for the rest of the months as formulas. Okay. There you go. So this value is 2900.048. Recharge from irrigation. Now we need to go to AB16. And then we're going to calculate the average value for irrigation, in this case for January. So this is for the entire time series data, right? So we can calculate this one. And now to estimate the percentage, well, what we can do is estimate the total value of irrigation recharge. So every month divided by the total value. Notice that I hit here F4, so I want to have this cell fixed. And I'm gonna paste it as formula. There you go. And the total is really simple. We just need to add these two. There you go. And here we can do something similar of what we did for recharge for irrigation. So far we are here. And then this is gonna be really simple. Okay, and this value of precipitation will bring it once again back from, I think we have it here in irrigation demand. We have this value in different worksheets. There you go. So it is this value, 2.105. You're gonna need to create the charts for this. Something that you should notice is that, look, that recharge from irrigation occurs during summer. Mostly recharge from precipitation occurs when the rain happens. So you can see that even though there is no precipitation, you are seeing recharge, and in this case from irrigation. And I think you can sorry, this is, there you go. So we can have those two, and in here, let me just there you go. So what we're going to do is to insert a chart, and in this case will be stacked. There you go. And now for the x-axis we are going to select the year. Ta-da! You have that one. And then you can work the other as we have done it in other parts of the exercise. And now for the water budget, we will have to go back here. And basically we have discussed this equation, which is change of storage equal inflows minus outflows. Here is a short video. And you can see places where we have groundwater overdraft and when you have saline intrusion. So basically here we're gonna now be estimating the water budget. Okay, so we'll go back here to our two documents and in here. So what we're going to be doing is we're going to be recalling the municipal water use, and if you remember, that one we haven't in this one, baseline demands. So if we come back here, we have urban, we have rural, and we have agriculture. Okay. In this case, we can sum all of them. Sorry. Now what we can do is select this and paste it as formula. Sorry. There you go. And this was filled up, so that's okay. Now, so we are all the way until here. Okay. Recharge from recycled water. And basically in here in this cell, so basically this is the historic recharge from the aquifers, but we'll go here to cell H42, and then we're going to predict, or we're going to consider that we're going to have in the future the average of the last 5 years. Okay. There you go. Sorry. So so we have now the time series data from recycled water, and for the aquifer recharge, remember that we just calculate that one in here, the total recharge. And then we can do the same for here. So the total water sources will be the sum of these two. And now here we can do the mass balance, right? So we are all the way until here. Now, remember that is the previous storage plus inflows minus outflows. In this case, we have an initial storage, but it will be 900 plus, in this case, the inflows that are in column J minus the outflows that are in column G. So that will be for this first value. And then in here, I'm just gonna recall the previous one plus the inflows minus the outflows. Now this one I'm gonna copy and paste it in this column. And we should be here, calculated all of this. We can now let me see, yeah, have a chart that shows this one, how it's been reduced, the aquifer storage, and for the x-axis we are going to consider the years. Okay. So that will be there. Now, this is, I mean, there are some questions in here, but mostly what you can see here is that overall the aquifer storage is going down, right? And there will be some questions about it. Now, what we are going to do, and I'm gonna move this one out of the way. Okay, so there you go. Now in here we have the historic outflow of Pajaro River, right? And what we're going to do is to repeat that time series data from 2021 and on. We cannot know how much water will be flowing in the Pajaro River, but we can just consider that the hydrology will be the same, and then we'll see how the system responds. So now we have repeated the time series data for here. For the return flow here, what you're seeing is that we are considering that there will be some return flows, that it will be the indoor share for municipal times the municipal water use, the indoor share times the rural. So remember that we have we calculated indoor and outdoor urban demands and rural demands. So all the water that is indoor, we're considering that water will be recycled. Okay, so in this case in P11, well, that will be the return flow, right? When water is disposed, it will be disposed and send it back into the river. So that will be it. So this is basically, this formula is the indoor share times the municipal, the indoor share times that minus the recycled water. And basically in here, here it is, formula, and that will do it. So the Pajaro River outflow will be this, the stream flow plus the return flow of these two. So basically I'm gonna just copy this one and then paste it all the way here. Basically what you can see in here, for instance, excuse me, well, these are the sum of these two, and in this it's basically going here. So Q93 over R93, which are these, Q93 over R93 of this one. So this will be the percentage. So of 100, basically the indoor is 49 out of 100 gallons, and this is 59 gallons over 170. So this is the percentage times that demand. That's what it's doing there. Now, in terms of the water year type, and this is, I just add these two, and basically you will get the Pajaro River outflow. Okay, now, in order to determine the water year type, basically here we are defining some thresholds based on the percentiles. So this will be very low. So if the lowest flows that occur below the 33rd percentile, the 66th percentile, and the highest flows. So in this case, what we're going to use here is this if statement that basically it says if it is greater than a given threshold, then type it dry. If it is greater than another given threshold, type it wet. Otherwise, it will be moderate. And that's what is happening there. You can see that this is showing the in-stream flow demands here and the annual values. So basically in here, once we have all of this, we will estimate what will be the in-stream flow demand depending if it is dry, it will look for this value. If it is moderate, it will look for this value, and if it is wet, it will look for this value. Okay, so basically what we are going to do here is go to cell S11, which is the one that I'm already, and use this formula just for looking for those values. There we go. And the same there we go. Let's just put this one in the center. And then here for compliance, what we're going to be doing is saying that if the river outflow is greater than this, then it was in compliance. Otherwise, it was not. So basically, that's what this is going to. Sorry. This is what this equation will do. And there you go. And it will tell us when it's not complying and when it is complying with the environmental flows, at least in volume. Then here what we're going to do, estimate is this reliability, how often in time it was complied. So it will count how many times it made environmental recommendation. And that will do it, 59%, which is what we have in here. And basically what this is asking you is that you plot the Pajaro River flow. So this can be sorry. And then this environmental demand. And what you need to do is to select this. Once again, hit Control and select this other one. And then insert a chart that has both, right? Like this. And the one thing that is missing is the x-axis. And that will be in here, the years. And now it looks like what we are asking on the tutorial. Thank you for watching. Now for the extra points, it's actually quite easy to do this. So basically what you need to do is to follow the instructions what are in here. So you just go to cell D84, and in this case you're gonna be looking for the here. There we go. So this what basically is doing is looking for the annual value, and it is multiplying times this percentage of urban water use. So it's going to that month and using this percentage to multiply that annual value. So that's what it will do here. The rural one, it will actually do the same. So this will be in this cell E84. For agriculture, it is going into the monthly time series data that we calculated for agricultural water demand, and then this will be the sum of the three. Now what you can do is copy this and paste it as a formula. There you go. Okay, now for the recycled water demand, you have to go to cell H84, which is this one, and then look for this formula. It's kind of already telling us about it, right? There you go. Okay, for the aquifer recharge, we already have time series data. Which is in the previous, in the recharge precipitation and recharge irrigation, we have those two time series data already calculated there. And off you go. Then here will be the sum of these two. And finally, the mass balance, it will be very similar. So previous storage plus inflows minus outflows. Previous storage plus inflows minus outflows. And there you go, it's all the way up there. And now when you have something like this, you can calculate the aquifer storage chart. And for this one you can use here the date as your x-axis. Okay, yeah, thank you for watching.